Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will be the fourth to cover section 4.2 for Intro to Statistics, considering one sample means with the t-distribution, and will be a full example of working with the hypothesis test while incorporating the t-distribution. We have here that New York is known as the city that never sleeps. A random sample of 35 New Yorkers were asked how much sleep they got per night. They averaged 7.73 hours with a standard deviation of 0.77 hours. And does this data provide strong evidence that New Yorkers sleep less than 8 hours per night on average? We will use an alpha of 0.05 level of significance. First, what we will do is state the hypotheses. The null and alternative hypotheses, remember, should be using the value that we are assuming is accurate. We should not have sample values in our hypotheses. The null hypothesis is that the mean is equal to 8 hours, that the average amount of sleep they get is 8 hours. Whereas what we're trying to show, specifically shown with the last sentence of, do these data provide strong evidence that New Yorkers sleep less than 8 hours per night on average? We're trying to show alternatively that the mean is less than 8 hours. To do so, we have a few things we're going to need to do first. Namely, we need to check the requirements that are needed to determine normality. The first requirement is that we have a random sample or a randomized experiment. In the second sentence, it explicitly states a random sample of 35 New Yorkers were asked, so we do have a random sample. The second condition, making sure that the population is either normal or the sample size is greater than or equal to 30. Remember that we can have both and still be okay. However, in this case, if we look at, again, the second sentence, we have a random sample of 35 New Yorkers. 35 is bigger than 30, so we have a big enough sample size that we don't need to concern ourselves with the shape of the population. Lastly, we also want to check to make sure that the sample size is less than 5% of the population size, otherwise known as the check for independence. In this case, we have to recall that we are analyzing individuals that live in New York, and we have selected 35 New Yorkers. Without knowing the population of New York offhand, we can pretty confidently say that 35 New Yorkers is less than 5% of the population of New Yorkers. On the right side here, we have another box that we need to think about in order to remember what hypothesis testing really is. If the null hypothesis is true, what does the sampling distribution look like? Well, if that is the case, then that means that the mean itself is 8. The average is 8 hours. Whereas the standard error is defined based on the sample standard deviation because we do not have a population standard deviation to base off of. So we get the sample standard deviation of 0.77 divided by the square root of the sample size of 35, which results in a standard error of about 0.13. Recall that that means that we have 8 in the center here as our average, and we are analyzing where our sample mean is in relation to that population mean of 8. Since we expect that value to be less than that, because we have our alternative hypothesis set up in that way, we expect our sample mean to be somewhere less than that. And what we're trying to analyze is the p-value, or the shaded region in the tail away from that sample mean. This is our p-value. In terms of what sample values would be surprising, well, that depends on the p-value that we get. Values where the associated p-value is less than the 5% significance level would be considered surprising. Remember that this is all based on the alpha level of 0.05. Now that we know the setup, we can now knock down the rest of the problem and calculate the test statistic, the p-value, and get to our conclusion. First, to compute the test statistic and the p-value, The test statistic, recall that we're doing a t-test, not a z-test. We have x bar minus mu sub 0 divided by the sample standard deviation divided by the square root of n. That would look like this, 7.73 minus 8 divided by 0.77 divided by square root of 35, which results in a t-score of about negative 2.07, indicating that our value is about 2.07 standard errors below the mean. To determine the p-value, which again is the probability of observing data at least as favorable to the alternative hypothesis as our current data set if the null hypothesis were true, and that means what we're trying to find is 7.73 in relation to 8, which we know is a little bit more than 2 standard deviations below 8. So I'll indicate 2 dashes for 2 standard deviations. And I will label 7.73 a little bit more than 2 standard deviations below. What we're trying to find here is a shaded region beyond 7.73 to the left. This is going to be our calculated p-value. Now we can do this in 2 different ways. Since we are doing the t-test, we can use the t-test table that is in the appendix of our textbook, or we can follow the GeoGebra instructions as shown on the right here. In the Statistics tab of the GeoGebra probability calculator, we will select the t-test of a mean from the drop-down menu. So let's demonstrate how we would do that. Here I have the probability section of GeoGebra open here. And what we're going to do is go to the Statistics tab, and we are going to select, as indicated, t-test of a mean. The null hypothesis, remember, is that the mean is equal to 8, and we're trying to show the alternative hypothesis is that it's less than that. The sample mean we gathered was 7.73. with a sample standard deviation of 0.77 and a sample size of 35. With all of this in place, we get the values that we are looking for as a result, including the t-score, negative 2.07, as I indicated earlier, as well as a p-value of 0.0228, or 2.28%. That is also what is shown in the GeoGebra instructions on the right side. And that is going to be our p-value. With that p-value in mind, I will label that as well in the graph, that p-value being 0.0228 or 2.28%. We can make our conclusions. First, we will say because of the value of our p-value, 0.0228 compared to our alpha of 0.05, we will say that we will reject the null hypothesis and say that there is sufficient evidence to conclude that New Yorkers sleep less than 8 hours on average. Again, the reason for that is because our p-value of 0.0228 is less than our alpha level of 0.05. If we want to interpret the p-value specifically, we would say that if New Yorkers actually sleep 8 hours on average, which is what the null hypothesis is saying, we would thus say that there is a 2.28% probability, or 0.0228 chance, of getting a sample mean of 7.73 or lower. We phrase it specifically like this because, one, this is quantitative, so we are analyzing a mean, not a proportion. And what we're trying to say is the likelihood of seeing a value as extreme or more extreme than what was observed. What we've observed is a sample mean of 7.73, and to be more extreme than that would be even less than 7.73 based on an alternative hypothesis also being a less than sign. If you have any further questions, be sure to review the example videos or ask your instructor.